Tonight, we're going to talk about the sky. Not the whole sky, just one small, quiet, silver piece of it. The one that is hung above every night of your life without you ever really asking why it's there, or what it's doing, or what would be different if it simply wasn't. We're going to imagine a world without the moon. Not gone, exactly. Never having existed at all. Version of Earth that spun alone from the very beginning, with no pale companion watching over the tides, the nights, the slow tilt of the seasons. It's a strange thing to picture, familiar and unfamiliar at once. Before we start, if this is the kind of place you like to return to at night, it helps others find their way here too, if you tap that little button. One sleepy soul at a time. Now, close your eyes if you'd like, let your breathing slow, and let's begin. There is a moon above you tonight, most likely, somewhere behind the clouds or the ceiling or the curtain. It has been there for your entire life, and every life before yours, stretching back further than memory, further than language, further than the first eyes that ever opened to look up and wonder what it was. We rarely ask what it does. We simply accept it the way we accept gravity or breath or the color of the sky. And yet almost nothing about the world you know would be the same without it. The moon is thought to have formed a little over 4.5 billion years ago, when a body roughly the size of Mars, sometimes called Theia, collided with the young, molten Earth. The impact was catastrophic beyond ordinary imagining. Enough to melt continents, enough to fling a ring of debris into orbit around our world. Slowly, over time, that debris gathered itself into a sphere, a companion. Something that had never existed before was suddenly, quietly there, and it has stayed close to us ever since. If that collision had never happened, if Theia had passed by a little wider, or arrived a little later, or simply never existed at all, Earth would have kept spinning as it was, fast, unaccompanied, and tilted at whatever careless angle its early formation happened to leave it. There would be no second light in the sky, no pale disk to mark the passage of the month, only the sun by day, and by night, only stars. Even now, as you lie still, the moon is pulling on you. Gently, almost nothing, but real. Its gravity reaches across 238,000 miles of empty space and tugs, faintly, on every ocean, every lake, every cell of water in your body. You have never felt it directly, and yet it has shaped the rhythm of nearly everything alive. Without the moon, the tides would not disappear entirely. The sun exerts its own gentle pull on the oceans, but they would shrink to a fraction of what they are now. The great rise and fall of the coastlines, the twice daily breathing of the sea, would soften into something barely noticeable, a whisper instead of a heartbeat. And yet, so much of life may have depended on that heartbeat. There is a theory, still debated, still uncertain, that the earliest forms of life may have first stirred in tidal pools, small basins along ancient shorelines, filled and emptied again and again by the pull of the moon. Chemicals concentrated, diluted, concentrated again. A slow, patient rhythm that some scientists believe helped nudge the first fragile molecules towards something we might call alive. We still don't know if this is true, but it is one of the quiet possibilities that a moonless Earth might never have offered. Beneath that theory lies another, stranger one. The moon may have stabilized Earth's tilt. Right now, as you rest, our planet leans at an angle of about 23.5 degrees. That lean is why we have seasons, why summer turns to autumn, why the light shifts and softens through the year. Without the moon's steady gravitational hand, some models suggest that tilt could have wandered, wildly, Over millions of years, Earth's axis might have swung anywhere from nearly upright to almost sideways, dragging entire hemispheres into and out of ice ages in patterns too chaotic to predict. It seems like something we should know for certain, and yet, astronomers believe, but cannot fully confirm, just how much the moon has calmed us. A world with a wandering tilt would be a world of extremes. Ice sheets creeping down to the equator in one age, tropical heat swallowing the poles in another. Not gradual, gentle seasons, but violent lurches between climates, generation after generation, with no fixed rhythm at all. And still, life might have found a way. Life is patient. Life adapts. But it would have been a harder, stranger road. And the creatures that walked it, if any did, might look nothing like us. Even the length of your day owes something to the moon. In the earliest years after Earth formed, a day may have lasted only 6 hours. The planet spun far faster than it does now, whipped around by the momentum left over from its violent birth. Slowly, over billions of years, the moon's gravity has acted like a brake, dragging against Earth's rotation, stealing a little energy with every tide. Today, a day lasts 24 hours. That number is not fixed. It is still slowing by about 2 milliseconds each century. Without the moon, that brake would never have been applied. Days might still last 6 hours, or 8, or 10, spinning past in a blur, sunrise and sunset chasing each other in a fraction of the time you're used to. Imagine trying to sleep in a world where night lasted only 3 hours before the sun came again. Even now, as your body slows towards sleep, it is following an ancient pattern, one shaped, in part, by a world with long, settled days and long, settled nights. A rhythm the moon helped make possible, long before anything alive was there to notice it. A faster spinning Earth would also have meant fiercer winds, storms of a different character altogether. The Coriolis effect, the same force that spins hurricanes and shapes global wind patterns, is directly tied to how fast a planet rotates. A world spinning several times faster than ours would likely have thinner, more violent bands of wind circling the globe, storms compressed and intensified by the speed of the turning Earth beneath them. Weather on a moonless world might be a near constant fury, quite unlike the gentler patterns we've grown used to. And yet, in that same imagined world, the night sky would hold its own kind of splendor. Without the moon's light to wash out the darkness, the stars would burn brighter, sharper, more numerous than anything you have likely ever seen. Every clear night would look like the deepest, darkest countryside sky, a cathedral of light stretching in every direction, uninterrupted. There is something in that thought worth resting on. A world that lost a great deal by never having a moon might have gained an unbroken window into the rest of the universe. Not fair, exactly. Not unfair either. Simply different. The universe rarely deals in loss without also offering something in exchange, even if the exchange is not one we would have chosen. You are made of elements older than the moon, older than the Earth itself. Carbon forged in the heart of some ancient, dying star, scattered across the galaxy long before our solar system existed. The moon did not make you, but it may have made it possible for creatures like you to exist here on this particular world at all. Even the color of your sky owes a little to that ancient collision. The impact that formed the moon likely stripped away much of Earth's early atmosphere, leaving room for a new one to slowly form. The one you're breathing right now, in and out as you drift. We still don't know exactly how different that early atmosphere would have looked without the impact. Thicker, perhaps, or thinner. poisoned by different gases, warmed or cooled by a different balance of chemistry. The air filling your lungs this very moment carries, in some very small way, the memory of a collision that happened 4.5 billion years ago. And beneath that memory lies another quiet truth. The moon is moving away from us, slowly, about 1.5 inches each year. In the distant future, hundreds of millions of years from now, it will be too far away to hold the sky in quite the same balance it does tonight. Eventually, perhaps, the very stability we've been describing will begin to loosen. Not suddenly, not violently, just a slow, patient drift toward a different kind of world. Even now, as you lie in the dark, the tide is somewhere rising, somewhere falling, in some far-off harbor you will never see. Constant, indifferent, beautiful in a way that asks nothing of you. You are part of this, part of a world shaped by a chance encounter in the earliest, most violent chapter of its history. A world that could have turned out so differently, in 10,000 small ways, if one ancient collision had simply never occurred. Let's rest here a moment. Let the thoughts settle, the way sediment settles at the bottom of still water. There is no need to hold on to any of these facts. They will still be true tomorrow, whether you remember them or not. Breathe in and out, slow. Let's continue. The moon has no light of its own. Every glow you've ever seen it cast, silver on water, pale on snow, soft through a curtain, is only sunlight reflected off gray, ancient rock, a borrowed light. And still, it is enough to have shaped mythologies, calendars, tides, and the sleep of every creature that has ever looked up and felt, for a moment, less alone in the dark. Even now, animals across the world are timing their lives by that borrowed light, whether or not the sky is clear enough tonight to see it. Coral in warm oceans still spawn together on certain moonlit nights each year, guided by a rhythm no one fully understands. Without the moon, that rhythm, that quiet, synchronized signal shared across an entire reef, might never have had a reason to exist. And yet, beneath that mystery lies something even stranger. Nocturnal animals the world over orient themselves by moonlight, use it to navigate, to hunt, to avoid being hunted. A moonless world would be a fully dark world every night, without exception. No waxing, no waning, no soft in-between. Just an endless, uniform blackness, broken only by starlight. We still don't know how differently life might have adapted to that kind of dark. Perhaps eyesight would matter less. Perhaps other senses, hearing, scent, some form of primitive echolocation, would have taken its place instead, spreading further and further across the animal kingdom, shaping bodies and behaviors in ways we can only guess at now. Even you carry a quiet echo of moonlight in your own biology, whether you've ever noticed it or not. Some researchers believe human sleep patterns shift subtly around the full moon. A little less deep sleep, a little more time before drifting off, though the effect, if it's real at all, is small and still debated. It seems like something we should know for certain, and yet the truth of it remains just out of reach, like so much else about the moon's quiet influence. Beneath your feet, right now, the ground itself carries the memory of moonlight, not literally, but in the shape of the coastlines it helped carve, the deltas it helped build, the estuaries it filled and emptied for billions of years, over and over, slow enough to reshape stone. And still, if you trace it all back far enough, it begins with a single violent moment. A young Earth, a wandering body called Theia, and a collision so enormous it briefly turned solid rock into glowing liquid. Out of destruction, a companion was born. And out of that companion, a world was quietly, patiently, made livable in ways it might never have been alone. Let that sit with you for a while. Even as you drift, somewhere on the far side of the planet, moonlight, soft, reflected, ancient, is falling on an ocean you will never see, pulling gently at water that will rise and fall again in a few hours, exactly as it has for longer than there have been eyes to watch it happen. You don't have to hold onto any of this. It will still be there in the morning. It was there long before you, and it will remain long after. For now, all you need to do is breathe and let the weight of the day continue to lift. The word month comes from the word moon. Before calendars, before clocks, before the neat grid of days we now take for granted, people marked time by watching the sky change shape above them. Full, then waning, then dark, then new again, over and over, roughly every 29 and a half days. Without the moon, there would be no natural month at all. No easy, visible way to mark the passage of weeks beyond the changing seasons themselves. Early civilizations might have measured time very differently. By the stars alone, perhaps, or by the slow creep of the sun's position against the horizon, a subtler, harder rhythm to track. And yet, astronomers believe, but cannot fully confirm, that the earliest human calendars, etched into bone, carved into stone, were shaped directly by watching the moon's changing face. Some of the oldest known markings made by human hands appear to be lunar tallies, small notches counting the days between one full moon and the next, long before writing, long before agriculture. Someone, somewhere, was already watching, already counting, already finding comfort in a pattern they could rely on. Even now, that same pattern echoes through the modern world in ways you might not expect. Many religious calendars, older than most nations, older than most languages still spoken today, remain tied to the phases of the moon, marking sacred days by its light, rather than by any fixed date on a solar calendar. Beneath that history lies something quieter still. The moon gave early humans their first reliable clock, something predictable in a world that otherwise offered very little certainty. Weather that shifted without warning, seasons that came and went, animals that appeared and disappeared. The moon, at least, kept its promises. Full, then dark, then full again, endlessly, patiently, the same rhythm repeating for as long as anyone could remember. We still don't know exactly how differently human culture might have developed without that early, dependable rhythm to organize around. Perhaps time itself would feel less structured to us now, looser, more fluid, tied only to the sun's long yearly arc rather than the moon's short monthly one. And still, in a world without the moon, something else would have had to fill that role eventually. Humans are pattern-seeking by nature. We might have found our clock in the stars instead, the slow wheel of constellations rising and setting through the year, or in the tides of rivers swollen by rain, or in the migrations of animals timed by instinct rather than by any visible light in the sky. Even as you rest tonight, your own body keeps a kind of month of its own, quietly, without your input. Cycles of hormones and rest and repair that echo, distantly, the same 28 or so day rhythm the moon has always kept. Whether that's coincidence or something deeper remains one of biology's gentler mysteries. Let's rest in that unresolved space for a moment. Not every question needs an answer tonight. The moon is the only place beyond Earth that a human being has ever stood. 12 people, in total, walked across its gray, ancient surface. A surface untouched by wind, by rain, by any real erosion at all, so that footprints made there in 1969 remain almost exactly as they were left, and will likely remain for millions of years to come, undisturbed by anything except the occasional impact of a stray meteorite. Without the moon, there would have been nowhere close enough, nowhere reachable enough for that first small step to have happened at all. Not for a very, very long time. No nearby target for early spaceflight to aim toward. No natural first goal to inspire an entire generation to look upward and imagine themselves among the stars. It seems like something we should know for certain. How differently a moonless world might have approached the whole idea of leaving Earth. And yet, astronomers and historians alike can only speculate. Perhaps space travel would have developed more slowly, without so close and visible a destination to aim for. Perhaps it would have leapt further, faster, toward more distant and difficult targets, simply because there was no easy first step available. Even now, the footprints left behind up there are quietly, permanently a part of human history, fixed in gray dust, in a place with no wind to erase them, no rain to wash them away. A stillness Earth itself has never been able to offer any mark we've made upon it. Beneath the surface of that stillness lies something almost unbearably quiet. The moon has no atmosphere to speak of, no air, no weather, no sound. If you stood there yourself, you would hear absolutely nothing. Not wind, not your own footsteps, only the astronauts' own breathing and their voices carried by radio rather than by air. And yet, from that silence, they looked back and saw, for the first time in the history of our species, the whole of the Earth at once. Small, blue, fragile-looking, hanging in an ocean of black. Many of those astronauts have said it changed something in them permanently, a feeling some later called the overview effect. A sudden, overwhelming sense of the planet's unity, its smallness, its precious and singular fragility. You are part of that same small, blue, fragile world tonight. Whatever country you're in, whatever language surrounds you, whatever borders happen to sit between you and someone else, from that distance, none of it was visible at all. Just one shared, quiet, spinning home. Even as you rest, that same view is available to anyone who leaves far enough behind. It has not changed. It will not change, not for a very long time. Earth remains small, blue, precious, whether or not anyone is looking. Let that thought rest with you now, the way it rested with them. Without the moon, the night sky's brightest object would simply be gone. Venus, on its best nights, is bright, brighter than any star, but nothing close to what the full moon offers, casting real shadows, silvering entire landscapes, turning night into something softer than full darkness. Without it, every night would fall the same way, dark and then darker, all the way until morning. Astronomers believe, but cannot fully confirm, that early human night vision, and by extension, early human behavior after dark, was shaped significantly by the presence of moonlight roughly half of every month. On moonless nights, even now, in places without artificial light, the darkness is close to absolute. It's disorienting if you're not used to it. Early humans, and the creatures before them, would have needed to adapt to something like that every single night, forever, if the moon had simply never existed. Beneath that thought lies a strange kind of gratitude. So much of what we consider ordinary, walking outside after dark, gathering by firelight, watching shapes and shadows shift across a moonlit field, depended on a companion most of us never think to thank. Even predators and prey alike evolved their behavior around lunar light. Some animals hunt more successfully under a full moon when visibility is high. Others hide more carefully during those same nights, retreating into burrows and shadows, wary of being seen. A moonless world would have erased that entire calculation, replaced it with a single, constant condition, night after night after night, forever unchanging. We still don't know exactly how differently the evolutionary story of nocturnal life might have unfolded under those unchanging conditions. Perhaps predator and prey would have relied far more heavily on scent or sound or touch, senses less dependent on a fickle, half-present light in the sky. And still, in that imagined dark, something else might have flourished. Bioluminescence, perhaps? Light generated by living things themselves, fireflies and deep-sea creatures, and glowing fungus, filling in for a moon that was never there to help. Life has a habit of finding its own light when it needs to. You are, in your own way, part of that same long habit, carrying warmth and awareness and a kind of inner light through darkness every single night of your life, moon or no moon, sky clear or clouded, needing nothing from the world outside to keep gently, quietly going. Rest in that now. You don't need any light at all, right now, to simply be here. Even as you rest, your body has followed a rhythm your ancestors likely inherited from a world with a moon in it. One shaped, in part, by the balance of long days and long nights that lunar tides once helped establish back before any of this history had a name. The moon's gravity is strong enough to pull not only on oceans, but on the solid crust of the Earth itself. The ground beneath your feet, right now, rises and falls by a small, imperceptible amount twice a day, tugged gently upward and back down by the same distant force that moves the tides. You have never felt it. It has never stopped happening. Without the moon, that quiet, constant flexing of the Earth's crust would be far weaker, present in a much smaller way, thanks to the sun's own gravity, but nowhere near as strong. The whole planet would sit just slightly stiller than it does now, unmoved by any nearby companion. We still don't know whether that subtle flexing has played any real role in geological activity. Some researchers have wondered whether it might gently influence the timing of earthquakes or volcanic activity, though the evidence remains thin, more suggestion than certainty. It seems like something we should know, and yet the Earth keeps many of its deepest processes well hidden from us, even now. Beneath the ocean floor, hydrothermal vents pour heat and minerals into the deep sea, feeding entire ecosystems that have never seen sunlight at all. Tube worms, blind crabs, bacteria that draw energy from chemistry instead of light. These ecosystems likely owe little to the moon directly, and yet even here, in the deepest, darkest parts of the ocean, the tides still move, still shift the water above in slow, patient rhythms reaching all the way down. Even you, resting now, are made mostly of water. Roughly 60% of your body, by weight, is the same substance that rises and falls with the tides every single day. The moon does not pull on you the way it pulls on the ocean. You are far too small, too solid, too dispersed for that. And still, there is something quietly poetic in sharing so much of your basic composition with the very thing that moon has spent billions of years gently, endlessly moving. Let that settle now, the way water settles when it's finally still. If the moon had never existed, total solar eclipses. The astonishing, brief alignment where the moon covers the sun almost perfectly, revealing its pale, ghostly corona for a few fleeting minutes, would never have happened either. It's a strange coincidence, one astronomers still find remarkable. The moon is about 400 times smaller than the sun, but also about 400 times closer to Earth. And so, from our exact vantage point, the two appear almost precisely the same size in the sky. No other known moon and star relationship in our solar system lines up so exactly. It is, as far as we know, simply a coincidence of proportion and distance, unrepeated anywhere else nearby. Without it, humanity would have missed one of the most striking natural spectacles available to any civilization. A sudden midday darkness, temperatures dropping within minutes, birds falling silent, stars appearing in a sky that was blue moments before. Historical records from cultures all over the world describe eclipses with a mixture of terror and awe, long before anyone understood what was actually happening above them. We still don't know how differently early astronomy might have developed without eclipses to observe. Some historians believe the study of eclipses helped early astronomers understand orbital mechanics far sooner than they otherwise might have. A natural experiment, repeating every so often, offering clues about the shapes and movements of distant bodies. And yet, that same alignment is slowly disappearing because the moon drifts a little farther from Earth every year. In a few 100 million years, it will appear too small in the sky to fully cover the sun. The last total solar eclipse, someday, will happen. And after that, only partial ones, forever, for whatever kind of life remains here to watch. Even now, as you rest, that quiet countdown continues, so slowly it will never touch a single human life directly. Not yours, not your children's, nor their children's, nor countless generations after that. Some kinds of change happen so slowly, they might as well be permanence from where you're sitting. Let that be a comfort tonight. Some things really do stay the same, for as long as you or anyone you'll ever know will need them to. Beneath the moon's gray, cratered surface lies a story of violence written across 4.5 billion years. Asteroid impacts, some enormous, pockmarking its face over and over, with nothing like Earth's wind or rain or shifting continents to ever smooth them away. Earth has faced the same bombardment over the same span of time. And yet our planet's surface looks almost entirely different. Younger, smoother, its ancient scars mostly erased by weather, by oceans, by the slow, constant churn of plate tectonics folding old rock back down into the mantle and pushing new rock up to replace it. Without the moon, Earth's history of impacts would still be largely hidden from us the same way. But we would have lost our clearest evidence of just how violent that early history really was. Scientists have used the moon's undisturbed craters almost like a fossil record for the whole inner solar system, counting and dating impacts there to estimate how often Earth itself, right below the same rain of debris, must have been struck too. It seems like something we should know for certain. How many enormous impacts our planet has actually endured, and yet astronomers believe, but cannot fully confirm, the true number, because so much of that evidence has simply been erased by Earth's own restless, ever-changing surface. Even now, the moon keeps a kind of memory Earth cannot keep for itself. A record of violence? Yes, but also, quietly, a record of survival. Every crater up there is a moment when something enormous struck, and something else, the moon itself, simply absorbed it and continued on, unchanged in its slow orbit, unbothered in any way that mattered. You are made, in your own way, of survived things too. old wounds, old weather, whatever this particular day happened to throw at you. And still, here you are, still turning, still continuing on, exactly like that quiet, patient, cratered companion above you. Rest now. Let the day's small violences settle the way old craters settle, present, but no longer sharp, no longer urgent, simply part of the shape of things. Even as you breathe tonight, in whatever room or bed or quiet corner you found for yourself, there is a very small, very real chance that a few atoms in your body were once part of the moon. The impact that formed it, all those billions of years ago, was violent enough to fling debris not only into orbit, but in some cases, far beyond it. Some material likely never returned to Earth or coalesced into the moon at all, but drifted instead through the solar system. Some of it eventually falling back to Earth as tiny meteorite fragments over the many billions of years since. We still don't know exactly how much of that scattered material eventually found its way back into the water, the soil, the air, the long chain of chemistry that eventually became you. It is a small chance, a quiet one, but not an impossible one. Beneath that quiet possibility lies something larger. You are, in the most literal sense available to physics, made of star stuff. Carbon, oxygen, calcium, iron, all forged inside stars that lived and died long before our sun ever formed. That is not metaphor. It is simply how heavier elements are made, and some small fraction of that stardust, after passing through supernovae, through nebulae, through the long formation of our solar system, eventually became a planet and a moon, and eventually, impossibly, you. Without the moon, the material would have gone somewhere else. Some of it, perhaps never leaving the early Earth at all, absorbed back into the young planet before it fully cooled. The exact atoms that make up your body tonight would likely be arranged in a completely different combination, in some completely different form, on a completely different version of this same planet. And still, you would be here, in some shape or another. Matter finds its way into complexity, given enough time and the right conditions. That has always seemed to be true, moon or no moon, in this particular corner of the universe. Let that settle over you now, slow and heavy, the way a blanket settles. You are old, far older than you usually let yourself remember. And tonight, that oldness is allowed to simply rest. There is a word for the kind of moon you sometimes see low on the horizon, appearing far larger than it does higher in the sky. The moon illusion. It isn't real, not physically. If you measure it, the moon is exactly the same size near the horizon as it is directly overhead. And yet almost everyone who looks up sees it, feels it, is genuinely convinced the moon has grown. Scientists still don't fully agree on why this illusion happens. Some believe it has to do with how our brains judge size relative to nearby objects, trees, buildings, hills, that give the moon something to be compared against near the horizon, something absent when it sits alone, high in an empty sky. Others believe it's simply a trick of perceived distance, the mind unconsciously deciding that objects near the horizon must be farther away, and therefore larger than they appear. Without the moon, an entire category of human wonder, the shared, universal experience of watching a swollen, golden moon rise slowly over the horizon, would simply never have existed at all. No poems written about it, no paintings inspired by it, no quiet moment shared by countless strangers across countless nights of stopping whatever they were doing just to look. Even now, somewhere on Earth, someone is watching exactly that happen. A low, golden moon, rising slow and enormous over a hill or a skyline or an open field, feeling for a moment as though the sky has come closer just for them. We still don't know with total certainty why our minds play that particular trick on us. And yet astronomers believe it says less about the moon itself than about the strange, wondering, pattern-seeking minds that have spent so long looking up at it. You have likely felt that illusion yourself at some point in your life, stopped by a moon that seemed impossibly large, impossibly close, before it rose higher and quietly returned to its ordinary size. That feeling, whatever caused it, was real. Your wonder was real, even if the size was not. Let yourself feel a little of that wonder now, gently, without needing to understand exactly why. The far side of the moon, the half that never faces Earth, was not seen by any human being until 1959, when a Soviet spacecraft called Luna 3 sent back the first blurry photographs of a landscape no eyes had ever witnessed before. The moon is tidally locked to Earth, meaning it rotates at exactly the same rate it orbits us, so the same face is always turned toward our planet, month after month, forever. This wasn't always true. Early in the moon's history, it likely spun faster, showing many different faces to a young Earth, until tidal forces, over hundreds of millions of years, gradually slowed its rotation into the locked, permanent stare we know today. Without the moon, there would be no such thing as a far side to wonder about at all. No hidden hemisphere, no permanent unknown hanging directly above us, visible to nobody until the technology finally existed to go and look. It seems like something we should know for certain. What that hidden half looked like for all the centuries before 1959. And yet, for the vast majority of human history, an enormous, mysterious surface sat quietly out of view, endlessly turned away, keeping its secrets simply by the nature of its own slow rotation. Even now, the far side remains stranger than the near side in real, measurable ways. Thicker crust, fewer of the dark, smooth plains called Maria that give the near side its familiar face-like pattern, more craters crowded closer together. Astronomers believe, but cannot fully confirm, exactly why the two sides differ so much. Though most suspect it has something to do with the far side's exposure to more impacts over billions of years, unprotected by Earth's presence, the way the near side has always been. Beneath that mystery lies a small, quiet reminder. Even the things closest to us, the things we see every single night without fail, can still hold entire hidden hemispheres we've never once laid eyes on. You are allowed to have hidden sides too, quiet parts no one has ever quite seen. That doesn't make you any less whole. Even as you breathe tonight, tides are moving somewhere on Earth, rising in one ocean, falling in another, following a rhythm set in motion long before there were shorelines or oceans or anything alive to notice the water moving at all. Without a moon, that rhythm would still exist in some faint, sun-driven form. But the great tidal rivers, the vast mudflats exposed twice daily, the tidal marshes that shelter so much of the world's coastal life, might never have grown so pronounced, so vital, so central to entire ecosystems built around their twice-daily rhythm. We still don't know exactly how much of coastal evolutionary history depended on strong, moon-driven tides specifically. But many biologists believe intertidal zones, the strip of shoreline exposed and submerged twice a day, have been an unusually rich breeding ground for evolutionary experimentation, forcing creatures to adapt to two entirely different environments within a single day, over and over, for millions of years. And yet, in a moonless world, some other rhythm might have taken its place instead. life is remarkably good at finding structure wherever structure exists. Weather patterns, seasonal rainfall, the slow certainty of sunrise and sunset. The tides gave one path toward complexity. They were never the only possible path. Beneath the surface of any tidal pool, even now, tiny ecosystems are being reshaped twice a day. Filled with seawater, drained again, exposing small creatures to sun and air, and predators they were sheltered from just hours before. It is a harsh rhythm in its way, and also, perhaps, a formative one. You have your own tides, in a sense. Moments of fullness and moments of emptiness, moving through your days in patterns you may not always notice while you're inside them. Right now, this is one of the quiet, low moments. The emptying out kind. The kind that makes room for rest. Let it happen. There's no tide you need to fight tonight. If Earth had no moon, its axis, unstabilized, might tilt so wildly over millions of years that entire continents could drift between ice and heat in patterns no calendar could ever predict. This isn't certain. It's one of the more debated ideas in planetary science. Some more recent models suggest Earth's tilt might have been more stable than once believed, even without lunar influence, held roughly in place by the gravity of other planets, particularly Jupiter, tugging gently from a great distance. Astronomers believe, but cannot fully confirm, exactly how wild that wobble would have been. And yet, even the more conservative estimates suggest a moonless Earth's tilt would have wandered more than it does now. Perhaps not catastrophically, but enough to make seasons less predictable, climates less stable, and life's slow adaptation to any one particular set of conditions considerably more difficult to settle into. We still don't know for certain which version is true. The wild, chaotic wobble first proposed decades ago, or the gentler, more stable wander suggested by more recent research. Perhaps we never will, not with total certainty. Some questions about the deep past resist final answers, no matter how carefully we study them. Beneath that uncertainty lies a kind of comfort, oddly enough. Not knowing everything is not the same as knowing nothing. Scientists have narrowed the question, sharpened it, made it smaller and more precise over decades of careful work, even without arriving at a single, final number. You don't need a final number either, most nights. You simply need enough of an answer to rest on, enough certainty to let your mind loosen its grip for a while. Let this be enough for tonight. The moon is drifting away from Earth, slowly, permanently, at a rate of about 1.5 inches every year, roughly the speed your fingernails grow. It sounds insignificant, phrased that way, and on any single human timescale, it is. You will never see the moon look smaller in the sky during your lifetime, nor will your children, nor their children. For as long as anyone alive today is likely to be remembered by name. And yet, given enough time, hundreds of millions of years, eventually more than 1 billion, that slow drift adds up to something enormous. The moon will continue moving outward until, eventually, it settles into a much slower, more distant orbit, no longer able to fully cover the sun during an eclipse, no longer pulling quite so strongly on the tides, no longer breaking Earth's rotation the way it has for billions of years already. We still don't know exactly what the very far future holds. Whether the moon will simply continue drifting outward forever, or whether billions of years from now, other changes in the solar system, including the eventual swelling of the sun itself into a red giant, will overtake the story long before the moon's drift becomes the most important thing happening to Earth. It seems like something we should know for certain, how the story ends. And yet astronomers believe, but cannot fully confirm. The precise shape of an ending so far away it barely counts as our problem at all, not in any way that touches a single human life directly. Beneath that vast timescale lies something almost soothing. Whatever changes are coming, they are not coming for you. Not tonight, not this year, nor this century, nor for longer than human civilization has even existed so far. You are safe tonight, inside a stability so enormous, it will outlast every single thing you have ever worried about. Let that be enough to rest on. Even now, as you lie still, moonlight from tonight's moon, whatever phase it happens to be in, takes just over a second to reach Earth after leaving the lunar surface, reflected sunlight racing across 238,000 miles of empty space in barely more time than it takes you to blink. Without the moon, the night sky would still carry light from much farther away. Starlight that has traveled for years, centuries, sometimes millions of years before finally reaching your eyes tonight. In a strange way, a moonless sky might feel even more ancient than the one you actually have. Nothing nearby to draw your attention, only distant, impossibly old light, arriving from stars that may not even exist anymore by the time you see them. We still don't know exactly how many of the stars visible on a clear night have already died, their light still traveling toward us long after the source itself has gone dark. It's one of the stranger, quieter truths of looking up at all. You are never looking at the present. You are always looking at the past, layered many times over, one distance at a time. Beneath that strangeness lies the moon's own particular gift. Light that is, relatively speaking, almost fresh. A little over a second old. The most recent thing in the entire night sky, borrowed from a sun that is itself 8 minutes old by the time its light reaches Earth, then bounced instantly onward to you. Even as you drift tonight, you are surrounded by light of wildly different ages, arriving all at once, indistinguishable to the naked eye. Ancient starlight, slightly less ancient sunlight, and if the moon happens to be out tonight, the freshest light of all, barely a second removed from its source. Let all of it arrive gently. You don't need to sort out which light is which. You only need to let it wash over you and rest. Without the moon, ocean navigation for early sailors would have looked almost unrecognizable. For thousands of years, before satellites, before radio, before any modern instrument existed, sailors used the moon, its position, its phase, its predictable movement against the stars, as one of several tools to help determine their location on the open ocean, far from any visible land. It seems like something we should know for certain. How much of early exploration depended on a companion most people never think to credit? And yet astronomers and historians alike agree that lunar navigation, however imprecise by modern standards, played a meaningful role in humanity's slow, patient spread across the world's oceans. Even the tides themselves, driven largely by the moon, shaped which harbors were usable, which rivers were navigable, how far inland, which coastal settlements could safely dock large ships, and which could not. An entire geography of human settlement, quietly guided by a rhythm in the sky most of those settlers never fully understood. Without the moon, that same slow human spread across the world might have happened very differently. Perhaps more slowly, relying more heavily on the stars alone, or perhaps along different routes entirely, following coastlines shaped by gentler, sun-driven tides instead of the stronger lunar ones. We still don't know exactly how differently human history would have unfolded, story by story, decision by decision, across so many centuries and so many separate journeys. Some questions are simply too large, too tangled for any clean answer, and still, here you are, wherever you are, the product of countless journeys made by countless people who came before you, guided in some small part by a moon they trusted without needing to fully understand. Let yourself be guided now too, not toward anywhere in particular, just toward rest. Even the smallest living things on Earth may carry a distant echo of the moon inside them. Some species of coral, plankton, and even certain fish are known to spawn in tight synchrony with the lunar cycle, releasing eggs and sperm into the water on the same handful of nights each year, timed with a precision scientists still don't fully understand, though moonlight intensity appears to be at least part of the trigger. Without the moon, that synchrony would likely never have developed at all. Reproduction might still happen, of course. Life finds its own timing, one way or another. But the exact, almost eerie precision of an entire reef spawning together on a single predictable night might simply never have existed as a possibility. We still don't know exactly how these creatures sense such small changes in moonlight so precisely, especially those living deep enough that surface light barely reaches them at all. It seems like something we should know, and yet the mechanism remains only partly understood, even after decades of careful study. Beneath that mystery lies something quietly moving. Millions of separate organisms, with no way to communicate with one another directly, somehow arriving at the exact same moment, guided by nothing more than a shared awareness of the same distant light, a kind of unspoken agreement repeated every year for longer than anyone can say. You, too, are part of larger rhythms you rarely notice directly. Rhythms of rest and waking, hunger and rest again, shared quietly with billions of other people around the world, all of you moving through the same 24 hours in your own separate, private ways. Let yourself be part of that shared rhythm tonight. Somewhere, right now, countless other people are also lying still, breathing slow, letting go of their day. You are not doing this alone. Without the moon, the very concept of a blue moon, a second full moon occurring within a single calendar month, would never have existed, along with the phrase it gave us, still used today to describe something rare. The phrase itself is a little more complicated than it seems. A blue moon happens because the lunar cycle, about 29 and a half days, doesn't divide evenly into most calendar months, which run 28 to 31 days. Occasionally, that mismatch allows 2 full moons to land within the same month, an event that happens, on average, only once every 2 or 3 years. It seems like something we should know precisely, exactly how the phrase came to mean what it means today. And yet its history is surprisingly murky, tangled up in old almanacs, occasional misprints, and a 19th century magazine article that appears to have gotten the definition slightly wrong, before that wrong definition simply stuck, repeated so many times, it eventually became true by popular agreement. Without the moon, English, and countless other languages would be missing an entire small category of expressions built around it. Once in a blue moon, over the moon. Phrases so common most people never stop to think about where they came from, embedded quietly into daily speech the way the moon itself is embedded into the night sky. Present, familiar, rarely questioned. Even now, language keeps finding new ways to reach for the moon when it needs an image for something rare or wonderful or slightly out of reach. There is something quietly telling in that. Of all the things in the sky, it's the moon we keep returning to, again and again, whenever we need to describe the outer edges of ordinary experience. Let yourself rest at the outer edges of ordinary experience now, too. Just for tonight, just for a little while. You are, in this exact moment, 60% water, and every drop of it is technically, still subject to the moon's gravity, even the water resting quietly inside you. The pull is unimaginably small, far too small to feel, far too small to measure by any means available to your own senses. And yet it is not zero. Somewhere in the careful mathematics of gravity, the moon is tugging, however faintly, on you specifically, tonight, wherever you happen to be lying. Without the moon, that tiny, unfelt pull would simply not exist. One less thread, however faint, connecting your body to the wider architecture of the solar system. It changes nothing about how you feel right now. And yet it's a strange thing to consider, that even in something as private, as personal, as your own physical body, you are already, quietly, connected to something 238,000 miles away. We still don't know whether that connection means anything at all beyond simple physics. Whether it has ever influenced human biology in any measurable way, or whether it's simply a fact, true and mostly irrelevant, the way most facts about gravity tend to be at very small scales. And still, there is something almost tender in it, a gentle, invisible thread linking you to the sky, asking nothing of you, offering nothing you'd notice, simply existing quietly in the background of your body's own private physics. Even as you breathe, in and out, slow and steady, that thread remains, unbroken, unnoticed, simply, quietly there. Let it hold you a little tonight, the way it always has, without you ever needing to ask it to. The moon's surface is covered in a fine, gray, powdery material called regolith. The shattered, pulverized remains of billions of years of meteorite impacts, ground down again and again into dust finer than flour, in some places many feet deep, without any atmosphere to weather it, without wind or rain to smooth it. That dust simply accumulates, undisturbed, layer upon layer, for as long as the moon has existed. It clings to everything. Astronauts who walked across it described it as strangely abrasive, almost sharp under a microscope. Nothing like the soft, rounded sand grains found on Earth's beaches, worn smooth by water and time. It seems like something we should know for certain. Exactly how deep that dust runs in every location, exactly how old the oldest particles really are. And yet even now, decades after the last human footprint was pressed into it, much of the moon's surface remains only partially studied, its full history still being pieced together, one small sample at a time. Without the moon, an entire branch of planetary science, the careful study of an untouched, unweathered record of the early solar system, would have no comparable substitute anywhere nearby. Earth's own ancient history has been erased by wind, water, and shifting continents. The moon, silent and still, kept the record Earth could not. Beneath its gray, undisturbed surface lies billions of years of memory, preserved not through any effort of its own, but simply through stillness, through the absence of anything that might have disturbed it. There is something in that worth resting on tonight. You don't have to do anything, either, to be worth remembering. Sometimes stillness alone is enough to preserve something true. Without the moon, humanity's understanding of gravity itself might have taken considerably longer to develop. Isaac Newton, working in the 17th century, used the moon's orbit as one of his key pieces of evidence while developing his theory of universal gravitation, reasoning that the same force pulling an apple to the ground must also be the force holding the moon in its steady path around the Earth, simply acting across a much greater distance. It was, at the time, a radical idea that the heavens and the earth might obey the exact same physical laws, rather than following some entirely separate, mysterious set of celestial rules, as many before him had assumed. We still don't know exactly how much longer humanity might have taken to arrive at that same insight without such a large, nearby, carefully observable moon to study. Perhaps another path would have led there eventually. The orbits of other planets, perhaps, or the paths of comets. Astronomers believe, but cannot fully confirm, just how essential the moon's example really was to that particular leap of understanding. And yet, it seems fitting, somehow, that the very companion responsible for so much of Earth's stability and rhythm also helped humanity understand the invisible force holding the entire universe together in the first place. Even now, that same gravity, described first with the moon as its clearest example, governs everything from the fall of a dropped object beside your bed tonight to the orbit of galaxies unimaginably far away. One law, discovered partly by watching one quiet, patient companion in the sky, applying everywhere, without exception, forever. Let that same steady, universal pull hold you gently in place tonight, the way it holds everything else. If Earth had never had a moon, the search for life on other worlds might look different too. Many astronomers now believe that a large, stabilizing moon may be an important, perhaps even necessary, ingredient for a planet to remain habitable over the very long timescales life actually requires to develop. When searching for potentially habitable planets around other stars, some scientists specifically look for signs that a large moon might be present, reasoning that Earth's own moon may not have been a lucky accident so much as a quiet necessity. It seems like something we should know for certain, whether large moons are common or rare among the countless other planets scattered across the galaxy. And yet, astronomers believe, but cannot fully confirm, just how rare or common a pairing like Earth and its moon might actually be, given how few other solar systems we've been able to study in enough detail to know for sure. Without our own moon as an example, that entire line of questioning might never have occurred to anyone at all. We might never have thought to ask whether moons matter, whether stability matters, whether life needs something steady nearby, simply to have enough time and calm to develop in the first place. Beneath that question lies a quiet, humbling possibility. That life, wherever else it might exist in the universe, may be rarer and more fragile than we sometimes assume. Dependent not only on the right star, the right distance, the right chemistry, but also, perhaps, on the right quiet companion, holding everything steady for billions of patient years. You are the product of exactly that kind of steadiness. Billions of years of a planet held gently in balance, long enough for something as improbable as you to eventually exist and rest right here, right now. Even as you rest tonight, radio telescopes on Earth's surface are listening, quietly, to signals from across the universe. And some of the most sensitive listening happens deliberately on the moon's far side. The far side of the moon is permanently shielded from Earth's own radio noise. Every broadcast, every satellite signal, every piece of human communication that fills our planet's atmosphere, blocked entirely by 2,000 miles of solid rock. Scientists have proposed building radio telescopes there someday, in that permanent, natural silence, to listen for signals too faint to ever detect anywhere on Earth itself. Without the moon, that particular kind of cosmic silence simply wouldn't exist anywhere nearby. Earth's own radio noise would spread unobstructed in every direction, drowning out fainter signals from deep space that a shielded location might otherwise be able to catch. We still don't know what, if anything, such a telescope might eventually hear. That's rather the point of listening at all. You cannot know in advance what you might find in silence you've never had access to before. It seems like something we should know for certain, whether we are truly alone or simply too loud on a planet full of our own noise to hear anything else that might be out there. And yet, astronomers believe, but cannot confirm, what patient, careful listening from a truly silent place might someday reveal. Beneath that unanswered question lies a strange, quiet comfort. The moon has been waiting patiently for over 4 billion years for someone to make use of its silence. It is in no hurry. It has never been in any hurry. It will still be there, still silent, still turning, whenever we're finally ready to listen closely enough. You don't need to be in any hurry either tonight. The world will still be there in the morning, exactly as patient as the moon has always been. There is a kind of moon called a supermoon. When the full moon coincides with the point in its orbit closest to Earth, appearing slightly larger and brighter than usual, though the difference is often too subtle for casual observers to notice without comparison. The moon's orbit isn't a perfect circle. It's a slight ellipse, meaning its distance from Earth varies by about 30,000 miles over the course of each month. Without the moon, there would be no such variation to observe at all. No near point, no far point, no gentle monthly rhythm of slightly closer, slightly farther, repeating quietly overhead. It seems like something we should know for certain. Exactly how much brighter a supermoon really appears compared to an ordinary one. And yet even careful measurements suggest the difference, while real, is smaller than most people expect. Noticeable, mostly in photographs taken side by side, rather than in the fleeting, ordinary experience of simply looking up. Even so, supermoons draw crowds, draw cameras, draw a particular kind of quiet excitement that ordinary full moons rarely inspire, despite being nearly identical in most practical ways. There is something in us that responds to the idea of closeness, of slight difference, even when the difference itself is small. Beneath that response lies something worth noticing about attention itself. How a small, almost imperceptible change can be enough to make us look up again. Really look at something we'd otherwise walk past without a second glance. Let tonight be a small, quiet supermoon of its own kind. Nothing dramatically different from any other night. And yet, if you let yourself really notice it, worth pausing for anyway. Without the moon, an entire field of scientific instruments, retroreflectors, left behind by astronauts and used ever since to measure the moon's distance with extraordinary precision, would never have had anywhere to be placed at all. Scientists on Earth still, to this day, bounce laser beams off small mirrored panels left on the lunar surface during the Apollo missions, timing exactly how long the light takes to travel there and back to measure the moon's distance down to a matter of centimeters. It's one of the longest running scientific experiments in human history, still quietly collecting data decades after the astronauts who placed those mirrors returned home. We still don't know exactly how much more we might eventually learn from that quiet, ongoing experiment. New insights into the moon's internal structure, its slow drift outward, even subtle tests of gravity itself, still being refined by bouncing light off mirrors placed there more than 50 years ago. It seems like something we should know for certain, how precisely modern instruments can measure something so far away. And yet the answer keeps improving, year after year, as instruments grow more sensitive, as decades of accumulated data sharpen the picture further and further. Beneath that quiet, ongoing measurement lies a kind of patience worth admiring. No dramatic announcement, no sudden discovery, just light sent out and light returned over and over for over 50 years, slowly building a more precise picture of something already mostly understood. You don't need dramatic breakthroughs tonight either. Just small, quiet, repeated moments of rest, returning to you the same way that light returns. Steady, reliable, patient. Even now, deep beneath the moon's surface, there may still be a small, partially molten core. A quiet, lingering warmth left over from its violent birth, slowly cooling across billions of years. The same way Earth's own core is slowly cooling, just far more slowly and far less dramatically. For a long time, scientists believed the moon was simply cold and dead all the way through, geologically inactive, with no volcanoes, no earthquakes, nothing stirring beneath its ancient, cratered surface. More recent evidence suggests otherwise. The moon experiences small quakes of its own, moonquakes, some caused by the same tidal pull it exerts on Earth, flexing the moon's own interior just slightly, over and over, in a slow rhythm of its own. Without the moon, we would never have discovered that a small, seemingly dead world can still carry a faint, quiet pulse of activity deep inside it, largely hidden from any surface signs at all. We still don't know exactly how active that deep interior remains, or how much longer it will continue cooling before finally, eventually, going fully still. Astronomers believe, but cannot fully confirm, precisely how much warmth still lingers down there, this far removed from the violence of its birth. Beneath your own quiet, resting body tonight, there is warmth too. A slow, steady engine of biology, heartbeat and breath and warmth, continuing on beneath the surface of your stillness, much the same way the moon's own quiet interior continues on beneath its silent, motionless face. You don't have to be visibly active to still be alive, still be warm, still be quietly, steadily continuing. Let that continue now, gently, exactly as it is. Without the moon's gravity gently slowing Earth's rotation over billions of years, days would still be shortening. But from an even faster starting point, and possibly toward an even faster ending point too, depending on exactly how the planet's spin had evolved on its own. It's a strange thing to try to picture. A world spinning several times faster than the one, sunrise, chasing sunset in a blur, seasons and days both compressed into shapes that would feel almost frantic by comparison to the slow, settled rhythm you've grown used to. We still don't know exactly how such a fast-spinning Earth would have affected the pace of evolution itself. Some researchers have wondered whether longer, steadier days, the kind the moon helped make possible, gave early life more stable stretches of light and dark to adapt around, compared to the shorter, more chaotic cycles a faster spinning, moonless Earth might have offered instead. It seems like something we should know for certain, and yet, so much of evolutionary history depends on chains of chance events stretching back billions of years, each one nudging the next in directions no one could have predicted in advance. Removing the moon from that chain doesn't just remove a companion in the sky, it potentially reshuffles almost everything that came after it. Beneath that uncertainty lies a strange kind of privilege. Whatever chain of events led here, led specifically to a world slow enough, steady enough, patient enough to produce something like you, resting quietly at the end of an ordinary day. It happened. Against enormous odds, across billions of years, it happened. Let that be enough tonight. Not every mystery needs solving. Some are simply worth resting inside of, unfinished, exactly as they are. If you have ever watched the moon rise slowly over water, you've likely seen the long, shimmering path of light it casts across the surface, sometimes called a moonglade or moon path, stretching from the horizon almost to your feet, broken and reformed constantly by the movement of the water itself. Without the moon, that particular kind of beauty simply would never have existed. No shimmering path across a lake at midnight. No soft silver light rippling gently across the surface of the sea. The same water rising and falling in tides the moon itself helps create. It seems like something worth pausing on tonight. How much of what we consider beautiful about the natural world is not separate from physics, but made entirely out of it? The moonglade exists because light reflects, because water moves, because gravity holds the moon in its steady orbit, month after month, exactly where it needs to be for any of this loveliness to occur at all. We still don't know exactly why humans respond so consistently across so many cultures to this particular kind of light on water. Why it feels peaceful rather than simply neutral. Why it draws people outside at night just to stand and watch it for a while. And yet, astronomers believe, but cannot fully confirm, that some part of our response to moonlight may be deeply, quietly ancient, inherited from countless earlier generations who relied on it, who trusted it, who found in it a small, steady comfort against the wider darkness. Even as you rest now, somewhere in the world, that same silver path is stretching across some quiet body of water, exactly as it always has, whether or not anyone happens to be standing there to see it. Let yourself imagine it gently, a long, quiet, silver path, reaching all the way to stillness. Even now, as you drift closer to sleep, your body is following a rhythm scientists call the circadian rhythm, an internal clock, roughly 24 hours long, that governs when you feel alert, when you feel tired, when your body naturally wants to rest, and when it naturally wants to wake. This rhythm is primarily driven by sunlight, not moonlight. Light exposure during the day, darkness at night, cueing your brain to release the right hormones at the right times. And yet some researchers have wondered whether a much fainter, secondary rhythm, tied loosely to the moon's own monthly cycle, might also play some small role in human sleep, subtly shifting sleep quality across the roughly 29 days between one full moon and the next. The evidence for this remains mixed and modest at best. Some studies have found small effects, others have found none at all. It seems like something we should know for certain, whether the moon truly touches your sleep in any measurable way. And yet the honest answer, for now, remains uncertain, more open question than settled fact. Without the moon, this entire minor mystery simply wouldn't exist to wonder about. Your sleep would still follow the sun's clear, dominant rhythm, uncomplicated by any fainter, secondary pull from somewhere else in the sky. And still, there's something comforting in the uncertainty itself. The idea that even now, after everything we've learned, your own sleep might still be touched, faintly, by something as old and quiet as moonlight. Not proven, not disproven, simply possible. Let that quiet possibility rest alongside you now, unresolved, exactly the way most good mysteries are best left before sleep. Without the moon, there would be no such thing as moon gardens, spaces deliberately planted with pale, night-blooming, light-reflecting flowers designed to be enjoyed specifically after dark, under moonlight, when their white and silver petals seem to glow softly against the darker shapes of ordinary daytime plants. Moonflowers, evening primrose, night-blooming jasmine. Many of these plants evolved their pale colors and strong nighttime fragrance specifically to attract nocturnal pollinators, moths especially, who navigate partly by moonlight and partly by scent, drawn toward the brightest, most fragrant blossoms available in the dark. Without the moon, that particular evolutionary strategy might never have developed in quite the same way. Pale, light-reflecting petals are far less useful in a world with no moonlight to reflect at all. Just starlight, faint and diffuse, offering little advantage to a flower trying to stand out in complete darkness. We still don't know exactly how differently nocturnal pollination might have evolved without lunar light to work with. Perhaps scent alone would have carried more of the burden, or perhaps nocturnal pollinators themselves would have evolved differently, relying more heavily on other senses entirely. It seems like something quietly worth appreciating tonight. An entire, gentle category of flowers that exists specifically because the moon exists, blooming pale and fragrant in gardens all over the world, timed perfectly to a light most of us rarely think to credit. Even now, somewhere, a moonflower is unfurling slowly in the dark, its white petals catching whatever light happens to be available tonight, patient and quiet, exactly the way you are patient and quiet right now, unfurling slowly toward rest, the largest volcanic plains on the moon, the dark, smooth patches visible even to the naked eye, forming the loose shape some cultures have called the man in the moon, are called Maria, Latin for seas, even though no water has ever touched them. Early astronomers, looking up with some of the first telescopes, mistook these dark, flat plains for actual oceans, giving them names like the Sea of Tranquility and the Sea of Serenity, names that stuck even after later observation revealed them to be nothing more than ancient, hardened lava, flooded across the moon's surface billions of years ago by enormous volcanic eruptions. Without the moon, we would have lost that particular, gentle misunderstanding. An entire vocabulary of imagined seas, named with real tenderness by people looking up and doing their best to make sense of the pale shapes they saw, long before they had any way of knowing what those shapes truly were. It seems like something worth appreciating tonight, how even a mistake made carefully and honestly can leave behind something beautiful. The Sea of Tranquility. The Sea of Serenity. Names now permanently attached to some of the most historically significant places humans have ever physically visited, still called seas, even though everyone alive today knows perfectly well they hold no water at all. We still don't know exactly why the far side of the moon has so many fewer of these dark volcanic plains than the near side. One of several small, lingering mysteries about why the two hemispheres differ so much from each other, despite forming from the very same violent birth. Even now, the Sea of Tranquility sits quietly overhead some nights, dry and ancient and utterly still, carrying a name given to it out of tenderness rather than accuracy, and somehow, all these centuries later, still perfectly, quietly fitting. Let yourself rest in your own sea of tranquility tonight, however imagined, however metaphorical. Sometimes a name given out of tenderness is exactly the right one. Without the moon, an entire category of folklore, werewolves, lunar madness, the old word lunatic itself, drawn directly from luna, the Latin word for moon, would simply never have had anything to attach itself to. For centuries, many cultures believed the full moon caused strange behavior in people. Sleeplessness, restlessness, even outright madness. An idea so persistent, it worked its way permanently into language, into medicine, into folklore repeated across countless cultures with only minor variation. Modern research has found little solid evidence to support most of these old beliefs. Careful studies of hospital admissions, crime rates, and sleep patterns around the full moon generally find no significant, reliable connection at all. And yet the belief persists, quietly, even now, among people who otherwise trust careful evidence over old folklore in almost every other part of their lives. It seems like something we should know for certain, once and for all. And yet, astronomers and psychologists alike suspect the belief endures not because of any real effect, but because of how human memory works. We tend to notice and remember the strange nights that happen to coincide with a full moon, while quietly forgetting all the ordinary nights that also happen to have one, and passed by completely unremarkable. Without the moon, that particular blend of folklore, memory, and gentle self-deception would never have found so perfect and so visible a target to attach itself to. And still, there is something almost affectionate in it. Even the myths we've mostly outgrown say something true about how much attention we've always paid to that quiet, silver shape overhead. Watching it, wondering about it, weaving stories around it, for as long as there have been people to look up at all. Let your own mind rest from wondering now. Whatever stories tonight holds for you, they can simply be stories. Nothing to solve, nothing to explain, just quiet company on the way to sleep. Even as your breathing slows further, somewhere far above the clouds, or the ceiling, or whatever separates you from the open sky tonight, the moon continues its same unhurried orbit. Roughly 27 days to circle the Earth once, relative to the distant stars, and about 29 and a half days to complete a full cycle of phases, from new moon back to new moon again. That small difference between the 27-day orbit and the 29 and a half day cycle of phases exists because Earth itself is also moving, orbiting the sun. So the moon has to travel a little farther each month just to catch up to the same alignment with the sun as before. Two motions layered on top of each other, quietly producing the rhythm you've watched your whole life without necessarily knowing the reason behind it. Without the moon, that layered rhythm simply wouldn't exist. No waxing, no waning, no slow, gentle cycle unfolding above you, night after night, for your entire life and every life before it. We still don't know exactly how differently human timekeeping, human folklore, human art and architecture and religion might have developed, absent that one particular, repeating shape in the sky. So much of what we've built, calendars, stories, songs, quiet moments of shared wonder between strangers who will never meet, has been shaped, at least a little, by watching that same slow cycle repeat. And yet, astronomers believe, but cannot fully confirm, precisely how much of human culture depends on any one particular influence. History is tangled. Causes and effects blur together, layer on layer, the same way the moon's own two motions blur together into the single, simple rhythm you've always known. Let the layers of your own day blur together now too. You don't need to sort them out tonight. Just let them settle quietly, the way the moon settles into its own unhurried path, night after night, without ever needing to hurry toward anything at all. There is a particular kind of quiet that settles over a landscape under a full moon. Not silence, exactly, but a kind of stillness, a softening of edges, shadows falling in slightly different directions than they do by day. Everything a little more silver, a little more hushed. Without the moon, that particular quality of quiet would never have existed. Nights would simply be dark, uniformly, completely dark, without the gentle, silvered version of the world that moonlight offers roughly half of every month. It seems like something worth sitting with for a moment. So much of what feels peaceful about nighttime, the hush, the softness, the sense of the world slowing down and turning inward, has been shaped, at least in part, by a companion in the sky most of us rarely think to thank directly. We still don't know exactly why moonlit stillness feels so different from ordinary darkness, psychologically speaking, though some researchers believe it has to do with just enough light to make the world visible, without enough light to make it urgent or alert. A middle ground, enough to see shapes and shadows without enough to demand full attention. And yet, whether or not the moon happens to be visible tonight, wherever you are, that same quiet stillness is available to you regardless. You don't need moonlight to slow down. You don't need silver edges or soft shadows to let your own edges soften too. Let them soften now. Let the stillness settle over you the way moonlight settles over water, gently, completely, without asking anything of you in return. Without the moon, the sky above ancient civilizations would have looked profoundly different. No eclipses to record, no monthly cycle to build calendars around, no bright, close, ever-changing shape to inspire gods and myths across nearly every culture that has ever existed. Nearly every mythology humans have ever created includes some story about the moon. A goddess, a rabbit, a face, a ship sailing across the night sky, a slowly rotating wheel of light and dark. Different cultures, separated by oceans and centuries, independently looked up at the exact same shifting shape and found, again and again, some story worth telling about it. It seems like something we should know for certain. Why so many separate cultures arrived at such similar kinds of stories, entirely independently of one another. And yet astronomers and anthropologists alike suspect it says less about the moon itself and more about something universal in how human minds respond to mystery, a shared, patient impulse to make meaning out of whatever quiet, unexplained shape happens to hang above us, night after night. Without the moon, humanity might still have found other things to build stories around. The sun, certainly, or the stars, or the slow wheel of the seasons. But something about the moon in particular, close enough to study, changeable enough to wonder about, present enough to feel like a genuine companion rather than a distant, unreachable point of light, seems to have made it an unusually rich subject for story across nearly every culture in nearly every era. Even now, whatever story you were told as a child about the moon, a face, a rabbit, a man, a goddess, is quietly part of a much longer, much older tradition of people looking up and reaching, gently, for meaning. Let yourself reach for a little of that same old comfort now. You don't need a specific story tonight, just the quiet knowledge that people have always looked up, always wondered, always found something worth holding on to in that same patient, familiar shape. Right now, as you rest, the moon is somewhere in its endless, unhurried orbit, new or full, or somewhere quietly in between, rising or setting, or simply sitting low and patient below the horizon, invisible but not gone, never gone, simply out of sight for a while. That's true most nights of your life, whether or not you ever look up to check. The moon doesn't need your attention to keep doing what it's always done. It doesn't pause when you're not watching. It doesn't wait for you to notice before continuing on its same slow, careful path. There is something worth resting inside of in that thought. So much of what holds your world together, the tides, the seasons, the length of your days, even the small, invisible pull it exerts on the water inside your own body, continues quietly, faithfully, whether you're paying attention or not. You don't have to hold any of this up yourself. You never did. The moon has been doing its patient, steady work for over 4 billion years, long before you existed, and it will keep doing that same quiet work long after you're gone too. You were never responsible for any of it. You only ever got to rest inside of it. Let yourself rest inside of it now, fully, without needing to hold anything else up at all. We have covered tonight a version of the world that never quite existed, an Earth without a moon, spinning fast and unaccompanied through a slightly different history. Its seasons wilder, its nights darker, its tides gentler, its whole shape subtly, thoroughly different from the world you actually live in. And yet the world you actually live in carries all of this quietly inside it. Whether you've ever thought about it before tonight or not, the length of your day, the rhythm of the tides, the seasons turning steadily through the year, the pale light sometimes falling through your window at night, all of it, in some way, touched by a companion that arrived through violence billions of years ago and has stayed close ever since, holding this small, blue, spinning world a little steadier than it might have been alone. You were part of that steadiness, not separate from it, not observing it from outside, but woven into it completely, made of the same ancient elements, carried along by the same patient rhythms, resting tonight under the same sky that has settled over every living thing that came before you, all the way back to whatever quiet, tidal beginning first allowed life to take hold here at all. There is nothing you need to do with any of this, no fact to remember, no lesson to apply tomorrow. You can simply let it settle, the way sediment settles, the way tides settle, the way your own breathing is settling now, slower and slower and slower still, in and out. Not fast, not urgent, just this, just breathing, just the quiet, steady pull of rest, drawing you gently downward the same way gravity draws the tide, in and out. You have carried enough today. You don't have to carry anything else now. Somewhere above you, whether you can see it tonight or not, the moon continues its same slow orbit, exactly as it has for over 4 billion years, asking nothing of you, expecting nothing of you, simply continuing, patient and quiet while you rest. And you can rest now. Everything is still. If you happen to still be awake, you can go ahead and watch the next chapter now. If not, good night. Sleep well. You've earned it.